Next example in analyzing the graph of a function. Okay, so let's go through this. The first question asks you, what is f of negative 2? I forgot to label this. Well, first of all, let's label all the points that we know for sure. So this point here is negative 2, negative 2. This point here is negative 1, 2. This is 0, 0. This is 1, negative 2. And then this point is 2, comma 2. Okay, so I have all these points. I'm going to circle them. All right, so first question, what is f of negative 2? Remember, f of negative 2 means the x value is negative 2. What's the y value? Well, when x is negative 2, the y value is also negative 2. So f of negative 2 is negative 2. Next question, what is f of 1? Well, when x is 1, y is negative 2. So f of 1 equals to negative 2. What is f of 0? When x is 0, the y is also 0. So f of 0 is going to be 0. X value, y value. X value, y value. You got 1, negative 2, x is 1, y is negative 2. 0, 0, x is 0, so is y. Okay. B, what is the domain? Well, the domain, okay, so the domain is referring to the x values. So this arrow, it tells you that the x values, they keep going indefinitely, they keep decreasing in this direction, and they keep increasing in this direction. So the domain is negative infinity to positive infinity. Why? Because this arrow tells you that this function is going to get smaller and smaller and smaller. So for every x, as it gets smaller and smaller, you'll have a y value. Same thing on this side. It keeps getting bigger and bigger and bigger, so for every x, you will have a y value. Okay, so that's negative to positive infinity. What about the range? Okay, so the arrow tells you that in this direction, the y's keep getting infinitely small. In this direction, they get infinitely big. So the range is negative infinity to infinity. On one side, they get infinitely small. On this side, they get infinitely big because of the arrows. So it's negative infinity to infinity. Okay, what are the x-intercepts? The x-intercepts, these are points where the graph crosses the x-axis. Okay, so I'm going to circle them. Cross the x-axis here, here, and here. Now these points, they are not labeled, they're approximations. So I'm just going to approximate. That kind of looks like negative 1.8. So my first x-intercept is negative 1.8 comma 0. The graph also hits the x-axis here at 0, 0. So my second x-intercept is 0, 0. It also hits the x-axis here. Looks like maybe like 1.8. So I'm going to approximate that to be 1.8 comma 0. So I have 3 x-intercepts, 1, 2, and 3. The graph hits the x-axis at 3 different points. Okay, now my y-intercept. Y-intercept is where the graph hits the y-axis. Okay, so the graph hits the y-axis. This is the y-axis at this point, which is 0, 0. So in this case, our x and y-intercepts, they happen to be the same, or one of them. Next question says, what does x equal to when f of x is 2? All right, so remember, f of x equals y. This is the y value. So the question is, what is the x value when the y value is 2? So this is why y equals 2 right here. On the graph, we have 2 different points. We got this point, and we have this point. So x equals negative 1, y equals 2. X equals 2, y equals 2. Okay, in other words, f of negative 1 is 2, and f of 2 is also 2. So these are going to be the values of x, where f of x equals to negative 2. Okay, now let's get to the increasing, decreasing. Let's get to the fun stuff. Let's do increasing first. Okay, I'm going to get rid of this decreasing thing. Increasing means, well, first let me label this. Okay, increasing is where my y values are going up. So in other words, if I'm going from left to right, where's my function going up? So my function is going up here. It's increasing, my y values are increasing here. But that's not it. They're also increasing here on this portion of the graph. So what I highlighted in red, this is where the y values are increasing. They're increasing here. So again, if you just go left to right, you're looking at where's the graph going up. Where's the graph going up? It's going up in these two regions. How do I represent that in interval notation? Well, this region And we're looking at x values when we're looking at the interval. So the x values, because of the arrow, it means on this side the x's it gets smaller and smaller, so that's negative infinity. And it stops increasing when x touches negative 1. So when x reaches negative 1, it stops increasing. So I'm going to have negative infinity, negative 1. Even though negative 1 is on the graph, we use a parentheses because at negative 1, 2, it's neither increasing nor decreasing. Because I have another portion of the graph that is also increasing, I'm going to put a union, because there are two different solution sets. It starts increasing again when from x equals 1, and then as x's get bigger, so it's 2, 3, 4, etc., the y values get bigger as well. So from 1 to infinity, the function is also increasing. Okay, so here's what this tells you. From x values of negative infinity to negative 1, this is the x value of negative 1, the function is increasing. From the x values of 1 to infinity, the function is also increasing. Okay, that's F. G says, where is the function decreasing? So decreasing means that going left to right, the y values are going down, they're decreasing. So this middle part that I'm highlighting in blue, this is where the function is decreasing. This is where the y values are going down. So we're going 2, 0, negative 2. The y values are going down. Now, what's the interval for that? The interval refers to the x values. So from x equals to negative 1 to x equals positive 1, this is where the y values are going down. This is where they're decreasing. Okay, so the left bound for that is negative 1, and the right bound is positive 1. So between x equals negative 1 and x equals positive 1, the y values are going down, which is why we have this interval. Now, like I said, this is not an easy topic to understand, so I want you to have a general idea, but think of some questions you have and come to class prepared, and we'll do more examples of this.